Hello everyone, and welcome to another lesson. Actually, place this properly, in fact. I'll put this in a full screen. Beautiful. Okay, welcome to our lecture number 8, in fact. And in this lecture, we'll be looking at our drive forensics, actual drive forensics. Now we're actually going to get to the part where we will practically be dealing with drives and analyzing drives to solve a case. So let's jump straight at it. So we're going to look at a bit of some theory when it comes to drive forensics, things like partition tables, drives, and so on and so forth. Okay, get started with this. So get a little bit of a backstory here. So what is it that we have to know exactly? So in context, get a little bit of context. Ooh, that is actually pretty cool. Okay, here, let's get a little bit of context. All drives have partitions, and a partition is just a section of a drive. So here, if we imagine a hard drive or drive disk, per se, it has partitions, which are just sections, essentially. And I'm sure you've seen you could have a certain USB device or something like that that can show up as multiple devices once you have connected it to your PC or something like that. That is due to that whole concept and idea of partitions. As I've mentioned, a device can have more than one partition, and the partition, how many partitions you can create, actually depends on the partition table, which is something that we are going to look at in a few. Partitions are basically identified by the operating system, and they will be mounted. So keep in mind, the device, the drive, has partitions, but when it has been mounted onto an operating system for you to actually view the files and all that, that is where it is called a volume. Okay, just a little bit of a backstory. Now, what is a partition table? Partition table, note. A partition table is a section. It's a certain section that contains the information and the entire mapping out of the hard drive. So if your hard drive looks something like this, you can have a certain particular section. Most of the time, it's actually the beginning of that hard drive. So there you would find your partition table, and the partition table sort of describes how the entire hard disk or hard drive is mapped out, how many partitions there are and what the partition types are, where does each one start and where does it end, and so on and so forth. And that's what you would find within a partition table. And there's two different types of partition tables that we're going to be looking at here. There's one called the master boot record, or MBR, and the MBR, it's a much older version of your partition tables, and this supports up to 2 terabyte disks. In context, it goes for up to 2 terabytes in size. So if you had like a hard drive that spans for up to 2 terabytes, you may have the ability to be using that master boot record partition tables. Okay, and it allows you for up to 4 entries. So you can only have up to 4 partitions when you are using that MBR. Okay, or you could use a much newer version known as GPT. It's a newer standard, and it supports well over 2 terabytes in space. So alternatively, you could use that instead. Okay, and another thing to note now is that GPT contains a backup header. It has a certain file within that place, and this is a backup in case that partition table itself fails and you can no longer map out where the partition start and end and their partition types. However, that little header file there is a backup in case of a redundancy. Okay. Now, looking at each partition, now we know how they are sort of described and mapped out. Now let's understand as in how each partition is. So partitions have different types. And the first partition to talk about is the FAT, or the file allocation table. And this one is more used in things like your USB drives. You would most normally find this. And ideally, the partition would start off with a certain file. So remember, you have this, like so. So in the beginning of an FAT, there's a certain file that's actually placed there in the beginning called that FAT, that file allocation table. And the FAT contains like somewhat of a spreadsheet. So this file has like a little spreadsheet that has pointers. and this sort of points at all the files that are inside that partition drive. So that's how it would look like. And ideally, this is very important to us in terms of digital forensics, due to the fact that you have the ability to delete files, obviously in a USB, but when you're using an FAT, basically what's happening is you're just removing the entry in the FAT, but the file itself is actually still within your drive. So it's not really gone if you are using FAT or in NTFS, which we'll look at in a few. Another thing to note is FAT16, which is a version of the FAT family, which supported drives of up to 4 GB in size. A much older version, in fact. And then we had FAT32, which is a much newer version, and this works for devices of, well, up to 32 GB. Okay. And another thing you might note, well, obviously, you've noticed that a USB drive can be accessed from almost every operating system. That's because, well, FAT versions work on all major operating systems. That is all the Windows, Macintosh, and Linux all alike. So it supports all those kinds. Okay. The beta version now is called the NTFS, which stands for New Technology File System. And this one was introduced by Microsoft for the Windows NT for those local drives. Theoretically, the NTFS can span for over 16 or up to rather 16 exabytes, which is pretty huge, but it's theoretical anyway. Okay, and it also permits encryption file systems, or EFS. It allows you to very much encrypt certain files so that they're only accessible provided that you give a password of some sort. That is the beauty of working with NTFS. So you might want to use that one over the FAT. Okay, then NTFS is supported by Windows devices. However, you can of course view files that are within an NTFS partition if you're using Macintosh or you're using Linux devices. But take note that it will be a read-only. So what we mean by this is, if you mount your NTFS partition, remember once you mount it, it becomes a volume. It's going to be read as well, read-only. This is to say that you do not have the ability to change files or add files or write files or delete files and so on and so forth. You don't have that ability to manipulate those files due to the fact that by nature NTFS will be read-only when it is mounted outside of the operating system of Windows. Okay. Much better version that we would like to look at now is EXT, which stands for the Extended File System. And the older version of EXT, EXT3, was developed by a very good guy called Stephen Tweedle in the early 2000s. I think that is like 2001 or so. And this EXT3 supports up to 32 terabit drives, which is a wonderful partition type, in fact. Secondly, the better version, EXT4, is a more modern version of that EXT family, and it supports up to a single exabit drives. And this is not theoretical, this is actual, by the way. Okay, with that in mind, there may be a case where the partition table can become corrupt. If the partition table becomes corrupt, you find that partitions will be read as raw drives. And this is because now that the system is unable to identify the partition type. Okay, and because of that, it will automatically be read as raw. And in digital forensics, if the case is like that a partition type is raw, then we'd have to start performing an autopsy or a post-mortem to attempt to basically recover that partition and potentially have those files. Okay, and obviously there are cases where you just want to use that USB device again. Then you're going to have to drop and then rewrite those partitions and recreate new ones, basically. Now, what are we going to look at in the practicality of all of this? Practically, we're going to be taking a look at how to perform an autopsy or a post-mortem using the special tool called autopsy. Now, attached to this, it's going to be in a separate video where we looked at a certain case called the M57 biz, the gene M57 biz. We looked at a case where we had to look through a case and see if someone had leaked files willingly or unwillingly so. But that's medicine for another disease anyways. And then we're going to take a look at how we can recover lost data actually without having to undergo the process of imaging essentially. Okay. Anyhow. So let's now take a look at how do we recover lost data without going through imaging. So what I've got in my hand now is a USB device. What I'm going to do right now is I'm going to just show you now. There we go. So here is my device manager. I've got a couple of drives and partitions that are actually shown right there. Only this one is mounted, by the way, which is my external drive. So now I'm going to mount a certain device right now, and you're going to see it appear right now. Okay, and this is a USB device, and this USB device is about 1 gigabyte in size. Okay, now how do we create partitions and delete partitions? We're going to use a special tool called GParted, which stands for the GNU Partition Manager. If you open GParted for the first time, you'll notice it like this. By the way, if you do not have GParted, you can install it on your Linux by using sudo apt install GParted, but it should come pre-installed on your Kali Linux, or if you're using Iron, you could find it pre-installed as well, or if you're using CSI Linux, you would find it pre-installed as well. Now, there's GParted. It is now analyzing the different disk devices. So this is how it is. You would find your disks right around here, and here's my current local disk right now. You would find the partition sort of laid out there, and this piece in yellow is showing you how much of that partition has been used up already. And this is my local Linux, by the way, which is in a about 93 gigabit partition, and about 83% or 83 gigs has been used already. Then we've got this, which is a little sector for my boot, which is an FAT32. And then I've got my Windows that is there, that's about almost 100 gigabytes, and only about 9 gigs of it has not been used. And then the remaining one is just an FAT32 partition, like so. Okay, and then I've got some unallocated space there, so it's sort of like mapping things out for me. Then here I've got an external hard drive, and this is a 3 terabyte external hard drive, 2.73. And then I've got just one partition created so far, which is mounted, so you'll know it's mounted if it shows a little key next to it like that. It's currently mounted on. Okay, and this is about 177 terabytes. Then I've got unallocated space right there. Then here's this USB that I've just mounted on right there. Okay, and yes, it is currently mounted, so you can go ahead and right click and then say unmount. You'll notice that it's no longer there. Okay, so I've just unmounted it right now. So now that I've unmounted it, I have now the ability to delete partitions, create partitions, or create a new partition table for what it's worth. If I want to create a new partition table, I can go ahead and say create partition table, and then I can choose from a list of partition tables like the normal GPT or MS-DOS, which is the equivalent of our MBR, our master boot record. Now I'm not going to change that. I'm just going to go ahead and delete this one that I already have, or maybe, I don't know, recreate a new one on top of it. Let's maybe have this as an FAT32 type. Okay, and then we'll write the changes there like so. And just like that, we are rewriting the sectors, deleting out a partition, and then creating a new one on top of it. Okay, I'm just going to close GParted. We should be able to see that partition show up again. Okay, so there we go. We're going to mount it as a volume. Perfect. Now, obviously, it is empty right now. So what I'm going to do now is create a file. Let's call this test. Okay, I've created a text file called test, and then I'm going to just open this and write something interesting for the sake of testing. Okay, and then let me just say hello Nash. Right, yeah, why not? Then I'm gonna Control S to save that. and then I can just get rid of it. So that's perfectly fine. I mean, the file is right there, and I can delete the file, of course. And because I deleted it, it would make sense that I would normally find it within my trash, right? If I right click on it and then I can restore it, it would go back to its original place, which is right there. Perfectly fine. But what if I hit shift and then delete altogether? It would say, are you sure you want to permanently delete test? I would say, yeah, sure. I would permanently want to delete test. Now, obviously in the trash, it's no longer there. Now it is totally gone. But it's not really gone, in fact. Reason because it has just been deleted from the file allocation table. So we can use a special tool called TestDisk. Just gonna open this in the terminal. Okay. And then I'm going to open TestDisk like so. Okay. When you do that the first time, I'm going to just create a log from there. It will create a little log file from there. Then now I have to give my root password. So I'm going to type in my root password like so. There you go. And then here I have to navigate using my arrow keys to the device that I would like to analyze. In this case, I would like to analyze my verbatim store and go mini. So I'm going to do that. And once I find it, I'm just going to hit enter. Okay. And oops. Okay. Okay, there we go. Yes. Verbatim store and go. And then I'm going to use the left and the right arrows to select the bottom right here. And I'm going to use that proceed. Okay. Then normally once you get to this point, it's going to identify the partition table on its own. But if it doesn't, you can use those arrows to select the partition table that's relevant for that device. In my case, it's selected on its own the Intel partition table. So I'm just going to hit enter. And once you get to this part, you can analyze. If you want to write the master boot record code, you can do that. If you want to just show up some of the partition options, you can do that. Or you want to just analyze it and search for lost partitions possibly. But in my case, I just want the advanced stuff. And you'll notice here at the bottom, you've got some advanced stuff you could do. The type apparently says you can change the boot type, or you can change the partition type rather. And then the boot side of it, there when we hover over that boot, it says, well, I can attempt to do a boot sector recovery. Okay, what I would like to do here is actually the undelete, not the image creation or that. I would just use that undelete and hit enter. Then here, there we go. So you'll notice now that the file is not there anymore. We've got a testdisk.log, which is actually there. You'll notice it's not even highlighted in red. But the one that's highlighted in red, which has been deleted before, is this file, which is about 11 bytes. Okay, and this is the file that I want. So I'm just going to use my arrows to navigate through to that. Okay, now that I'm in it, you'll notice the options at the bottom sort of highlight what you would like to do. So I'm going to use the C to copy the current file. So I'm going to hit C on my keyboard. And then now it's going to take me back to the previous folder that I was in. Remember, I started my terminal from here. It's going to take me there. And then I'm just going to hit enter right where the dot is, because that's where I would like it to recover from. So once I've highlighted where it is, remember, you use your arrows to navigate through. Okay, and then I'm going to hit the C when the destination is correct. So once I get to the destination where I would like to open that file, I'll just then hit C, like that. Now that I've hit C, there is the file that has been recovered. If we read it, we should be able to find hello Nash within it. And just like that, we have recovered our file using that test disk. Okay, and then you can use your Q to quit, and you can proceed by hitting Q to quit out of test disk. And just like that, that's how we recover that. Okay, and then of course the remaining piece now is to look at autopsy. But for that, we have attached a video where we've looked at the M57 biz case, dealing through that drive forensics. So you guys have a look at that one, and I will see you all within the next one. Cheers.